In this video, I'm going to discuss vectors and the components of a vector. What is a vector? A vector is a physical quantity that has both magnitude and direction. Examples of these are displacement, velocity, acceleration, and force. Vectors can be written as you have a vector is equal to its magnitude, comma, and then direction. Other vectors can be written as a vector equals a constant times I hat plus another constant j hat plus another constant times k hat. So where I hat, j hat, and k hat are unit vectors, while a, b, and c are the components of this vector here. Vectors are represented by an arrow, and they are normally written in bold letter with an arrow on top of the letter. Okay, for example, for acceleration, we use A. We have A with an arrow on top. So we have velocity with an arrow on top, force with an arrow on top. Let's take displacement as an example. Let's say a car travels 40 kilometers north. So this is the magnitude, 40 kilometers. We have comma, and then north is the direction. In a diagram, so we have this arrow here that is pointing north. An arrow has a tail, so this tail represents the vector starting point, and the arrowhead gives us the direction of a given vector. So this distance from the tail to this point here, the tip of the arrow, is proportional to the magnitude of a given vector. So in this case, this distance, this length, is equal to 40 kilometers. This is the direction it's going north. So since d is a vector, it has a magnitude. Okay, its magnitude, d, without an arrow on top, or d with an absolute value symbol. In our example, d is equal to 40 kilometers. Or you can write d in this manner to be equal to also 40 kilometers. That is how we write the magnitude of a vector like d. Another example is f. So f represents force. So f equals, say, 25 newtons. Then we have 60 degrees north of west. So this vector can be written as we have 25 newtons. We have 120 degrees counterclockwise from the positive x-axis. Okay, let's show this one in a diagram. So we have this vector lies in quadrant number 2. We have, this is north, this is west, so we have 60 degrees north of west. So this angle is measured from west going north. So we have 60 degrees, so from west to north. So, and then if we use the positive x-axis as our reference line for the angle, then we have the positive x-axis here. So we measure the angle from this line. So we have 90 plus, let's say this is 30, equals 120 degrees. Or we have 180, this is 180, minus 60 is equal to 120 degrees. It's counterclockwise. So counterclockwise direction means positive angle. If we measure the angle clockwise, then we have a negative angle. Okay? Now, if we are going to make this 25 newtons, then you have 60 degrees west of north, then the angle is going to be measured from north going west. So this is going to be 60 degrees. So from north going west. This is west of north. So the magnitude of this force is F equal to 25 newtons. Okay. Components of a vector. If I have, for example, a vector, say vector A, and vector A lies in the first quadrant, so this vector has two component vectors. So they are AX, so it has an arrow on top, and AY also has an arrow on top. That's why we call them component vectors of A. So these component vectors are obtained by projecting A along the x-axis. Then we have AX. And how about AY? So we project the tip of from the tip of A towards Y. So we have now AY. Okay, so those are the component vectors of A. We have AX and AY. Now, if this vector is AY, here's the tail, then this vector here is also equal to AY. So meaning we can connect the tail of AY to the head of AX. So that's why we have AX and then AY. So meaning this vector A here, A is equal to the vector sum AX plus AY. Okay, so in vector form, we have A. This vector A here is drawn from the tail of the first vector. We have AX and plus AY. So from the tail of the first vector to the head of the last drawn vector is AX and AY. So that's why we can write A equals AX plus AY. So what are the components of A? So we have now AX and AY. Look at the components. So components have no arrow on top, so meaning they are scalars, but they can be positive or negative depending on the location of the location of the vector. It could be the first quadrant, second quadrant, third, or in the fourth quadrant. So look at the component vectors. So they have arrows on top. We have AX and AY, but the components have no arrow on top. We have AX and AY. So again, if this length is equal to AX, because these are magnitudes, this is AX, then this length is AY, so this is going to be AY, this length is also AY. If this vector is vector A, then this length is equal to A. Okay, we have AX, we have AY, and then we have the angle theta. This is measured from the reference line, the positive x-axis. Now, if, for example, if we are given A and theta, we can derive an equation for AX and AY. Okay, we can find the components of A. We have using cosine theta. Let us begin with AX. We have cosine theta is equal to AX over A. We have adjacent side over this length hypotenuse. So that's cosine theta. Then we can find, therefore, AX equals A cosine theta. Okay, how about AY? So given A and theta, we can use sine theta. We have sine theta equals AY over A. It's opposite over this length here, the largest length of the triangle. So therefore, I can now find AY to be equal to A sine theta. Okay, now in this case, since vector A lies in the first quadrant, so both components are positive. So AX is to the right, so to the right means positive component. Then we have an upward y component AY. It's also positive. So upward positive, then we have downward component is negative. To the left component is also negative. So that's why if a vector lies in quadrant number 2, then AX is negative, it's to the left, AY is upward. In the third quadrant, so AX is to the left, it's negative, AY is downward, it's also negative. In the fourth quadrant, we have an X component that is positive and a Y component that is negative. Okay, so AX can be positive or negative depending on the location of that vector in the Cartesian plane. Now, supposing that the components are given, so given EX and AY, how do we calculate the magnitude A and the value of theta? Because theta gives us the direction of a given vector. So for the magnitude, so we have this is A, so therefore A squared equals AX squared plus AY squared. We have a right triangle, so therefore A equals the square root of AX squared plus AY squared. That's for the magnitude of vector A. And for the angle theta, we can use, of course, tangent theta equals AY over AX. We have opposite over adjacent side. Therefore, theta equals arctangent of AY over AX. Okay. If, for example, we are given three vectors. We have vector A, vector B, and the third vector, vector C. So the angles are given there. So what are the components of each vector? What are the components of A? What are the components of B? And what are the components of vector C? So let's begin with the components of vector A. So we have AX and AY. So again, remember the formula to find AX. We have AX equals A cosine theta. So we have we have 3 meters, and cosine of, you need to know this angle. So I repeat, so we use the reference line here, positive x-axis as our reference line. So the angle, then we go counterclockwise so that the angle is going to be positive. So we have this 90, okay, this is 90 plus 30 equals 120, or we have 180, this is 180 minus 60 gives us 120 degrees. So AX equals A, or 3 meters, cosine of 120, and cosine of 120 is negative. You have negative 1.5 meters, okay, because vector A lies in quadrant number 2 with an x component direction that is to the left. Now for AY, so just replace cosine with sine, and then the angle stays at 120 degrees. So we have AY is A sine theta, we have 3 meters, sine of 120, then sine of 120 is positive, so we have AY equals 2.60 meters. So AY is positive because A has a component that is upward. It lies in quadrant number 2. How about the components of the second vector? So vector B lies in the first quadrant, so we expect the components to be positive, so to the right and upward. So we have Bx equals B cosine of 30. We have 30, this is 30 from the reference line. Then cosine of 30 is positive, so times 5, it gives us 4.33 meters. This is for the x component. So for the y component, so just replace cosine by sine, and the angle stays the same. We have 5 times sine of 30, it gives us a y component of 2.5 meters. The third vector has components Cx equals C cosine theta for the third vector. For C, we have 8 meters, cosine of 270, this is 270. If we go counterclockwise, we have 270, this is 270 plus 45 degrees. It gives us 315 degrees. So we have 8 meters times cosine of 315 degrees. Or if we are going to go clockwise, so from the reference line, it gives us negative 45. We have cosine of negative 45. So cosine of negative 45 equals cosine of 315. So it gives us 5.66 meters. And for the y component, so we have C sine theta C, we have 8 meters, sine of negative 45, and it gives us negative 5.66 meters. Because sine of negative 45 is negative, that's why the result is negative. But cosine of minus 45 degrees is positive, so that's why we have this positive result. Number 2 example. Okay, from the given pair of x and y components of a vector, so these are the x component, and the y component, the x component, y component, there are 4 of them, A, B, C, and D. The question is, determine the magnitude and direction of each vector. Okay, for example, in question A, we have AX equals 8 meters and AY equals 4 meters. In this case, we are asked, what is the value of A, vector A? So to find that vector, you need to know its magnitude, you need to know its direction. How do you find the magnitude? Remember the formula, A equals square root of AX squared plus AY squared. That's how you find the magnitude. Put the numbers, we have 8 squared plus 4 squared, we have 64 plus 16 gives us 80. Square root of 80 is equal to 8.94 meters. That's the magnitude. And for the direction, we need to know the angle theta. So theta equals arctangent of AY over AX. So we have tangent inverse of 4 meters over 8 meters. It gives us 0.5. We have arctangent of 4.5 is equal to, we have 26.6 degrees. Now, if you look at this result, it tells us that this is measured, remember this is measured from the positive x-axis. So therefore, we must show that a vector must lie in the first quadrant and that both the x component and the y component are positive. So we have x equals positive and y equals positive, so therefore this is correct. This is the correct value of theta, so measured from the positive x-axis. So we have vector A, this is 26.6 degrees from the reference line. So where AX is to the right and AY is upward. So therefore we can write A equals 8.94 meters, that's the magnitude, then comma, then we have a direction of 26.6 degrees. So meaning this is measured from the positive x-axis. Or in terms of the directions north, east, southwest, so we can write 8.94 meters, comma, we have 26.6 degrees north of east. So this angle is measured from east going north. How about this one? We have Bx equals 6 meters and By is negative 2.0 meters. So find the magnitude first. So same formula, we have B equals Bx squared plus By squared. So put the numbers. We have 6 squared plus negative 2 squared. We have 36 plus 4. It gives us 40 square meter. Square root of 40 is 6.32 in meters. How about the direction, the angle? So theta equals inverse tangent of By over Bx. We have negative 2 first over 6 meters, and you have negative 1/3 or negative 0.333 and so on. It gives us a negative value, negative angle. We have negative 18.4 degrees. So this result tells us that since the angle is measured from the positive x-axis and this is negative, so we go clockwise, so from the reference line. So meaning vector B must lie in the fourth quadrant. Okay, so if Bx is positive, so By is negative, so therefore this one agrees with this angle. Okay, so if you look at the diagram, so we have vector B is lying in quadrant number 4 at an angle of 18.4 degrees based on this reference line here, 18.4 degrees. So that's why we can write vector B to be equal to 6.32 meters in magnitude and comma, we have a direction of negative 18.4 degrees, or we have 6.32 meters, 18.4 degrees, then we have south of east. We have this is the south direction, we have east, so from east going south, 18.4 degrees. Then third, you know, the components are Cx is negative 12 meters and Cy also negative, we have negative 18.0 meters. So we can find the magnitude easily using the formula. We have C equals square root of Cx squared plus Cy squared. We have negative 12 squared plus minus 18 squared. Put the numbers, we have 144 squared for negative 12 squared and 324 for 18 squared. Then add, we have square root of 468 square meter, then square root of that is 21.6 meters. That's the magnitude. And for the angle theta, we have arctangent of Cy over Cx. We have negative 18 over negative 12. It gives us 1.5. Tangent inverse of 1.5 is 56.3 degrees. Now look at this result. This result tells us that the angle is positive. So meaning, in this case, a vector must lie in the first quadrant. But what happens here is that these are the components. We have both of them are negative. Then therefore the exact location of the vector is going to be in the third quadrant because the two components are negative. Let's look at the angle. So we have here it's in the third quadrant, so based on the components. Now if we're going to extend this line here, so this angle as measured from the positive x-axis, if we are going to extend this line, I repeat, this angle is equal to 56.3 degrees. So therefore, this is also equal to 56.3 degrees. Okay, so we have, say, tangent theta equals Cy, this is Cy, over Cx. Okay, so therefore, this is going to be the angle. this 6.3 degrees, not this angle based on the signs of the components. Therefore, the right angle, so based on this reference line here, we need to add this by 180. This is 180 plus 56.3 degrees. So that's that angle with theta prime. So we have 180 degrees plus 56.3 degrees. The result is 236 degrees. So therefore, vector C has a magnitude of 21.6 meters. In comma, we have 236 degrees, so measured from the positive x-axis. Or we can write this as C. This vector C is equal to 21.6 meters, comma, then 56.3 degrees south of west. This is south, this is west. So from west to south. How about if we have components like dx is negative 24 meters and dy equals 16 meters? So we can easily find the magnitude. We have square root of dx squared plus dy squared. We have negative 24 squared plus 16 squared. Let's put the numbers. So the square of this is this. Square of 16 is 256 square meter. Then add, so it gives us 832 square meter. Then get the square root. We have 28.8 meters. That's the magnitude. Then for the direction, we can find theta. We have tangent inverse of dy over dx. We have 16 over minus 24. Arctangent, and then it gives us negative 0.6667. So therefore, theta equals negative 33.7 degrees. So again, we need to look at these angles. It tells us that the vector lies in the fourth quadrant. But in this case, it turns out that this is not the correct angle because if you look at the components at dx and dy, dx is negative, dy is positive, so therefore, this vector here must lie in quadrant number 2. Let's look at the diagram. So we have number 2, there's vector d with an x component that is negative, and we have an upward y component, so meaning it's positive. So if we're going to extend this line here based on our result, supposed to be the value of theta is negative 33.7. If this angle is 33.7, then here is 33.7 degrees. So where the right direction, the right location of vector D is in quadrant number 2. That's why we can write the angle theta prime to be equal to 180, this is 180, minus 33.7 degrees. It gives us theta prime as measured from the reference line, we have 146 degrees. So therefore, we can now write D to be equal to 28.8 meters in magnitude with a direction of 146 degrees, or we have 20.8 meters, 33.7 degrees, then we have north of west.